I'm going to give it a second more. All right, while it's heating up, I'll just say. So I don't remember what title I submitted for this talk because you do it months in advance. I decided that when you're coming here, I'll pick the relevant topics for this group and see if it works. I think it's working now, it's warmed up, so I think we're okay.
Okay.
So I'm talking sort of about a broad area of research we're pursuing in my group, which we're calling visual anthropology. I'll explain what that means. But I'm particularly going to talk about, since this is a workshop that's focused on fashion, fashion in the wild and at scale. And I'll explain what I mean by in the wild and at scale as well. So I'm Kavita, Bala. I'm normally at Cornell. I'm on sabbatical and leave of absence at Rockstyle, the company I co-founded. I'll mainly actually talk about the Cornell work I've done with Kevin Madsen, who was my PhD student, graduated last year. He's now at Facebook, and Noah Snavely, who's my colleague. But I'll talk a little bit about the other work that's done, including some collaboration we had with Julian way back when. And I'll talk about how they all fit together. Okay, I think it's warmed up. That's blue and that's white, so I'm going to start. When rounding in images, you take a lot of them depending on what device you have on you, your cell phone, selfie sticks, or in the new world in the AR glasses that we're all apparently going to be wearing and walking around in. And there's a lot of great data sets that are out there. Shicktopia is one where people post various fashion ideas. It's really got amazing data that lots of people have looked at and analyzed. We take actually a slightly different tack from looking at data sets like Shicktopia because we look at another data source, which is an in-the-wild data source. So if you look at something like Instagram, people are also posting pictures of what they are dressed in, which actually is a representation of their personal style. So one of the things that we wanted to do is look at what happens if we can exploit that kind of data that's there in Instagram to understand fashion in the wild. And I realize that the top is cut off. Are people okay with that, or should I be futzing around with the projector? You guys are okay with? Yeah, all right, good. So there's millions, and you know, Instagram has millions and more of images, right? Billions of images. And so how do we, the scale of data that's available on that kind of data set, we wanted to understand what we could do with that. And that led to sort of what I'm calling this broader project of visual anthropology. Imagine an anthropologist of the future who has access to all that data, which is visual data. What can they learn about how we live? So what are the kinds of questions you might like to answer? Apart from how people dress, which is their personal fashion, how do we live? You know, what do we wear, yes? What do we eat? How do we decorate our homes? Who do we hang out with? How does our behavior in all of these axes change over time? So that's sort of a broader research agenda that my group is pursuing. Today I'm going to primarily talk about the top one, which is street style, because that's most relevant to this audience, which is can we come up with analysis of these large data sets to understand something about everyday fashion. And we're calling it street style because it's everyday fashion. And I'll then just briefly talk, actually these 3 papers of mine that were from a few years ago, I want to actually talk about them and more talk about how they could be used and areas of research we're pursuing to apply them to fashion and how I see that potentially developing in the future. All right, so what was the goal of street style? So this project, we wanted everyday users, not couture fashion, not fashion houses, but at the scale of hundreds of millions or tens to hundreds of millions of photos, geography, we wanted to understand how people live across the world. So we wanted data from the entire planet, basically, and across several years, so over time. And you'll see how that plays a role because the kinds of analysis we do is about space and time too, and understanding what's hot in what location. And we wanted to do analytics, fashion analytics, and also enable better visual discovery if we gave people the right tools to play around with this data. So we started off with Instagram, and we actually scraped data from 2013 to 2016. That's the earliest data we could get. And in 2016, they turned the spigot off and they made it so that you couldn't access it. But we have three full years of data. We also spread across the globe. So the yellow dots are the cities we sampled. We picked 44 cities. And you can see the blue dots, the blue colors actually represent where people have uploaded images. So they're pretty representative of the region of the world where people are actually uploading images. So that's the data we scraped. And what we did is we just took off-the-shelf components to recognize people in these pictures. So, for example, we used Face++ to do face detection. We used a deformable part model to do body localization and visibility. So those are the boxes around the body. We correlated the face boxes with the body boxes. And then we kept images cropped out the region that has a person to create these canonical crops of a face and a body. Note that we only do the upper torso, we don't do legs for various reasons. People often just take selfies, they take their upper body, so we don't have that many images of the lower body, but eventually we'd like to get, of course, a full representation of style. What you wear, you should capture the whole thing. All right, so we have these canonical crops, and we started off with 100 million photos, and then running all this face detection, etc., we arrived at about 8 million photos that we then analyzed, that I'm going to talk about. So what we did was, there's a lot of work on doing supervised learning in this context. 8 million photos, we made a contribution also in the supervision, but it's a relatively small one. We picked a very small subset, about 27,000 photos, and we annotated them with 12 attributes of fashion. And I'll tell you what those are in the next slide. And so it's a very small data set of supervision, but using that supervision, we're going to do a combination of training and unsupervised learning that we hope will result in good visual discovery. I'm sorry, I'm bad with this mic. Okay, so I told you I'll tell you what the attributes are. There were binary attributes and sort of multi-valued attributes. So for example, the color, that's the major color in the dress. And there are different values you can take: orange, blue, black, white, etc., red. Are you wearing a scarf or not? Neckline shape, there are a few values you can take there: U shape, V shape, etc. Different clothing categories, and other attributes are down there. Are you wearing glasses? Is the person wearing glasses or not? Hat, yes, no. Collar, yes, no. Sleeve length has a multi-value, etc. So you can see the paper for more details. It's actually not the most exhaustive at all taxonomy. We built off some existing work. There's lots of great work, as you all know, and several people in this room have contributed to the great work in this space. We built off some known taxonomies, and we just picked basic 12 attribute system. Going further, we're actually working with a fashion designer who is giving us a much more comprehensive taxonomy that we're hoping to annotate in the future. All right, so once you have that small amount of annotation, you can then train a supervised deep net on these known attributes. So that's what we did. We trained, it wasn't a very complicated, just a regular, I think it was the Inception network at that time, but we played with different architectures. We trained on those attributes, and so you know that when you train on these, you can then do classification. It tells you, is it black or not, etc. at the end. If you strip that last layer out of the trained network, then you'll end up with this embedding network, which is 1,024 dimensions. We took that embedding network, and then we projected down to 2D, and what you're seeing here is that visualization, the t-SNE visualization of those 1,024 dimension vectors, okay? Why am I showing this to you? Because it's interesting to actually look at it a little bit. This is, the whole object is visual discovery, so you should look at it. And then hopefully you'll discover things. So for example, you can see the blob on the right is sort of greenish stuff, bottom left is reddish clothing, bottom right looks like blackish clothing, etc., right? So you can spend a lot of time exploring this visualization. We've also posted this. But we wanted to go beyond and actually explore it more sort of rigorously or more comprehensively. And so then we took that data, we took that embedding, and we further ran an unsupervised clustering algorithm using a Gaussian mixture model to find 400 clusters in this embedding space. Okay? It's all good? Everybody's with me? Yeah. Okay. So now we have about 400 different clusters. What do these clusters tell us about clothing? So we see sensible things. So for example, here are the plaids. That's one sort of cluster with the cluster center. You can see their plaids. Jackets and layers, and horizontal stripes. So in fact, this embedding is behaving sensibly. The clusters look like they have a lot of logic. There's not random stuff in them. They actually have some visual coherence to them, some stylistic coherence to them. So this is good. But then you can actually look, dig a little deeper. So if you go and you look at these unsupervised clusters, actually what they do, apart from of course having the attributes that we had originally looked for, things like are you wearing a jacket or not, additionally, clusters capture how people are combining things together. So for example, these are examples of our top clusters. Each row is a single cluster. There's also an average image which shows the average of the cluster. And if you look at the average, it really jumps out to you what that cluster might be showing. So for example, the top one marked in green, you can see it's a cluster of somebody wearing a dark sweater of some sort and a lightish shirt, and in fact this is a cluster that's not a gray shirt, it's a striped shirt. And there are actually other places where you can see dark jackets that have a light shirt, etc. in the cluster. So they just come out and they tell you how people combine dark sweaters with what other elements underneath, even though that was not something we had actually collected in our original data. You can see other clusters here, bottom left are the plaids, and then going further, this is another cluster that popped out. We had collected whether there were graphics, but this cluster shows that there's really gray hoodies and t-shirts with a particular kind of graphic on it. So we have basically shown a kind of cluster that we didn't actually capture in the original data, but now we've revealed if somebody's trying to understand what kinds of fashions there are, well, people seem to really like wearing this. And in fact, if you were to add logo detection or something there, gray hoodie with Gap on it actually would show, right? So that's one way in which we're enabling sort of visual exploration. You can actually go farther. So this is basically, this visual clusters are basically giving us finer grained data than we had originally collected and trained for, which is great. So it's giving us more information than we had. But you can dig a little deeper because you can look at where the images come from by thinking about where in space and time they come from. So on the left are still the clusters I'd shown you earlier, but on the right we have a plot that shows basically which city those images are coming from and what time of the year they're coming from on the y-axis. So on the x-axis are cities. I remember I said we had 44 cities. On the y-axis is time, and you can see some immediate things. So the top 3 rows you can see have some very strong geographical correlation. If you look at the cluster, maybe you don't necessarily know the local wear of certain countries, but if you look at the cluster, you can see that, okay, on the top there seems to be some very, classic cultural, particular kind of culture's headgear. The middle 2 rows are the hijab. And on the bottom, we are actually not seeing a geographical clustering, we are actually seeing behavior related to time. So if you look at the y-axis, you can see that it's lighting up in January and February, and then when you go back and look at the cluster area, yeah, people wear jackets and hats in winter. So it says by looking at these clusters and looking at where they are in space and time, you learn about how people are dressing around the world. And in fact, the top cluster corresponds to Lagos and Cairo and Jakarta in the second 2 rows, and the bottom, as I said, was winter. So those clusters are localized in space and time. There are clusters that are not localized in space and time. So you can look at the clusters. So for example, there's a cluster of blue shirts, and in fact, everybody wears them all over the world. So if you ever go to a business meeting in a part of the world and you're not sure what to wear your blue shirt, it's going to be fun. Everybody wears them everywhere. There's also black shirts which light up everywhere, but it turns out that black polos actually light up more in the Indian subcontinent, which I had not appreciated. And then when I saw this, I was like, oh, that's very interesting. So you can learn things about how people dress just by looking at this data. So that's one way in which you can use this kind of analysis and exploration. Another way is that we wanted to look at, say, looking over time specifically. So what colors do people wear at different times of the year? So we plotted for white and black, and you can see white and black are opposite with respect to each other. And this was sort of to test the hypothesis. In the US, there's a rule that after Labor Day, people don't wear white. That's the general rule you're supposed to follow. And actually, sure enough, you actually see that. In July, etc., there's a lot of white, and it starts dipping down, and in October till January, etc., people don't wear that much white, and then they ramp up again during the summer months. So there's a very clear seasonal trend of white and black is the opposite of that. You can, of course, the US is in the northern hemisphere, you actually split that out across different cities, and actually cities in different hemispheres, and you notice if you look at the correlation matrix down there, you actually see, sure enough, all the southern cities are highly correlated with each other, southern hemisphere. Northern hemisphere cities are correlated with each other, and they behave opposite from each other. We wear white in summer for us, they wear white in summer for them. So these are all things that just pop out. They validate that the data and the behavior is actually sound. There's some statistical significance, it's making some sense. So we also thought, well, we're doing all this visual analysis. How does this, is this data that you can also get just from analyzing text? So for example, looking at Google Trends, can you just get the same kind of information from there? I'm going to present you sort of a plot of when people wear scarves versus when people type for scarves. Oops. that didn't work. Hang on. Sorry, I'm just going to see if I can enable that slide. Yeah, it's right here. Sorry, I hit it. You see my gory slide mechanics here. Okay, and if you plot the two of them on top of each other, you actually see there's something interesting going on. When they show up in photos, it seems firstly that they're correlated. They have similar shapes, which is nice. That makes sense. People wear scarves, and they search for scarves at about the same time of the year in winter. And you'll actually see though they search textually before they wear it, seemingly, and then they wear it for a longer period of time, even though they stop searching for it. I mean, our hypothesis is you search for it, you buy it, and then you wear it for many seasons, or at least 1 or 2 seasons, and that might explain this. Now, we need to do much more rigorous analysis to actually validate that, but you can see stuff in the data that reveals some interesting patterns that hopefully we can drill down deeper into. The other thing it would be great to do is, can we use this data to find unique events? So we were just browsing the data, and by the way, it's online, I'll show you the link shortly. And we started looking at we were just looking at different colored shirts, and we happened to be looking at yellow. And then we actually drilled down a little deeper, and there was yellow V-neck t-shirts. The graphics on them had a giant spike that had no other color and shirt behaved this way as this graph does. And so we were surprised by it. Any guesses? I'm sure some of you know. What is this? Why is there a spike of yellow V-neck t-shirts with graphics on them? No?
Football?
Yeah, that's exactly right. So when you go and you look at the cluster, it turns out that was the soccer, the World Cup soccer, and it was in Brazil that year, and basically South America lights up with that color. And if you look at the cluster, you look at it and you go, oh yes, they're wearing their team colors, and then everybody is wearing yellow graphics. So we're very excited about, as I said, this data set. We also did other things. So for example, we looked at what's typical clusters for LA versus typical clusters for Mumbai. And if you look, they look different. For starters, people in LA don't look the same as the people in Mumbai. And we actually gave it to an artist just because we were trying to see how do you capture a particular area. And artists basically created very different, what they feel was signature clothes in different parts of the world. Top is LA, bottom is Mumbai. So if you're just having fun with this, this is more to help with understanding. But as I was saying, we posted all this online. Go to streetstyle.cs.cornell.edu. You can actually play, you can enter different patterns, etc., and plot the popularity over time, the regional popularity. You can click on one of the cities, etc. So if you're interested in that, please go ahead and play with it. We'll be very excited to get feedback on it. All right. So that sort of gives you some idea of this one project that we've been working on. I'm going to actually now talk a bit about some future work and how that correlates with some of the previous work we've been doing in the group. So one thing that we didn't have in our attributes, but some other groups have actually had in their attributes, are materials in the clothing. Materials play a giant role in fashion and in clothing. If something is super uncomfortable or scratchy, you won't wear it. And so whether it's silk versus fur versus wool plays a role in how you think about materials. Some of it is, of course, in the textual data. Some of it is visually distinctive. Silk and velvet, for example, are very distinctive materials that you can tell the difference, and fur too. So we would like to add that kind of materials in the attribute system. For that, you would need fine-grained material recognition. And we had actually done some early work. It's called Materials in Context, which was in CPPR 15, on recognizing materials in the wild. But they didn't have fine-grained categories, and so we're trying to take the next step of recognizing fine-grained categories, particularly for fabrics and woods and stuff. Fabrics for clothing, wood for interior decor, different types of woods, so that we can do a better classification of that. So that's one area that I think will be fun to go in. Another area is sort of fine-grained recognition. So we've recognized that there's V-necks, and I said, the Gap hoodie kind of emerges in all of this. But it'd be great if you could just recognize that and look for it. And so I'll just talk a little bit about some work we've done in fine-grained search. This has actually now become the core technology of the company I've co-founded. And I'll talk about then how I see that potentially fitting in fashion. In fact, in some follow-up work that Julian and my students did, we actually looked at trying to use that for style compatibility. So I'm going to switch gears a little bit. I've been showing fashion examples now. I'll actually talk about a different project. That was actually in the context of product recognition. We are actually focused there on interior decor, furniture, and furniture retail. And the problem we were looking at is, imagine you go to your friend's home and you want to figure out what this thing is. Now this thing is particularly an interesting item because it's not obvious at all what it is. It's sitting out on the deck. It's some sort of outdoor garden thingy. It turns out it's actually a fire pit, which maybe if you go in and inspect and see charcoal in it, you'll figure out. But actually, not only do you want to know it's a fire pit, because that's moderately interesting. Ideally, if you happen to like this thing, you would like to know exactly which fire pit it is. It's a great bowl of fire, and you'd like to know where to buy. Right? So that's something that you can imagine people really want to have that capability. This is what we call the what is this thing? There's a flip side to this question is, now that I know what this thing is, where have other people used it? This, it turns out, plays a very big role in inspirational photography. So it turns out, yes, you can put it as a fire pit, but you can also use it as torches outside. And in fact, designers do really amazing things with all the kinds of products that are out there that frankly boggles my mind. I'm not able to think about all the creative uses they have. And it turns out that this ability to hook up consumers with exciting inspirational photography is a very, very interesting market that a lot of people are interested. Houzz and Pinterest, for example, this is sort of their main bread and butter, is inspiring people with inspirational photography. So those are companies that are really believe that this kind of inspirational photography is important. So these two questions, how do you solve them? So we had this paper in SIGGRAPH 15 that now is the core engine of GrokStyle, and I talk a bit about how we got it to work and how we use that technology. The core problem is basically that there's messy in the wild data. It's been taken at different angles, taken with different resolutions, different coloring, lighting, etc. You're not exactly sure how that looks. And meanwhile, there's very clean from the retailer data that's iconic or product or very clean. And your problem is that you're trying to find the relation between these two. So how do you do it? So 5 minutes, okay. We trained the Siamese network to learn a joint embedding. And I'll just show you, I'll look at the paper for details on how we trained the network and what we did there. But let me tell you what it achieves. After you've trained the network, you've learned this projection so that when you start with an iconic photo, you project into a particular part of the space, the style space, and all of these messy in the wild photos also should project to the same space. That would be the ideal goal, and that's what you're trying to achieve. And if they do that, meanwhile, things that are not this particular object should project to different parts of the space. So this has been done before in 2006 by Haskell, and we basically took that idea and then applied it in the context of this problem domain with some innovations along the way. So once you have this trained embedding, then the what is it question becomes straightforward. You project into the space and go and retrieve whatever the product data is. And what's particularly interesting is also, as I said, once you have this embedding, then the reverse problem also becomes enabled. The where is it used lets you project down here, and now the manufacturer or the retailer can go and figure out where are people using my product. So this is useful for them, but it's also useful for consumers to say how are designers using this product. So together we think that it gives you a powerful sort of tool for people to use. So here's a visualization of the space, and again, like the previous visualization, you'll see some sensible behavior. So for example, there's chairs with thin legs on the bottom right. This is only for chairs. There's a full visualization for all categories. There's office chairs on the top right, etc. But once you have this, now the what is it question, which is a hard visual search question, and particularly I'll show you this example. It's a transparent chair. So you get a lot of the background in the chair. How many of you know what this chair is? It's called fittingly the ghost chair. And so we search on the ghost chair, and in fact our top 3 results are different variants of the ghost chair, and in fact the third one is exactly the right one with the right handles, etc. Okay, so once we had this, in a follow-up project we actually looked at how could you use that in a completely different setting. So we were taking very, very different pictures of the same object to match them together in this embedding. But what if you flip that around and actually took pictures of different objects and matched them together saying, these are stylistically compatible. And that was a project joint with Julian. And so you're learning some sort of a style space now. So imagine if you had a shoe, you map into a particular location, and you know that this particular tank top goes with that shoe. Now you match it to that same location, use the same kind of a training framework, and if you do that, then what you have learned is an embedding where once you map into the shoe, you can find all the compatible, stylistically compatible objects in there. So those are the positive examples. You can also get negative examples, which are things that don't match. Where do you get this data? Well, we don't actually have that level of data or stylistically matching things that I think lots of people are working on it, and there's more work to be done there. In this particular project, we use the co-purchase data from Amazon, where if you bought a shoe, you might have bought the tank top too, and put it together. And Julian's been working with that data set and kindly gave it to us. And so that's a positive example. Negative example, we use the Haskell and our previous work. And once you learn that, now you can make a predictions like this. There's a lot of work that needs to still get done in this space, but just to give you an idea of what you can do, the green boxes are what the user said, hey, I have this, give me an outfit that goes with it, and the other stuff was paired with the green box. So on the left, you can see that's kind of sporty looking bike pants that went with what looks like the bike shirt, the red bike shirt. You can see this blue dress in the middle with these nice pumps that go with it. So we can make now recommendations that are hopefully stylistically compatible. As I said, we scratched the surface on this, there's a lot more to do. All right, so I'm on time. So to conclude, I talked to you about sort of, enabling large-scale analytics of fashion in the wild. I think that this can be a really powerful tool. There's a lot of noise, and in fact, the contributions are in very carefully trying to figure out how to get signal and not get bogged in the noise, and how to make sure that you're doing actually something that's statistically significant. So we've scratched the surface there, please play with it, but there's many, many exciting things to do. Richer taxonomies, richer materials, fine-grained recognition. I didn't talk about other people have worked on the space, automatic detection of trends and anomalies, etc. I showed you how you can do it in an exploratory setting, but it'd be great if you also had tools that automatically pop these up and said something crazy seems to be happening in this part of the world at this time. So there's lots of nice work that could be done there. Some has already started, and style understanding. These are the people who did all the work, particularly Kevin, who's now graduated, but Kevin's work is the street style work, and Sean and Bala are my other students, and Paul, who did the other work that I talked about. All right, that's it.